Hello, my little mathematicians. Today I'm going to review with you how to find the GCF, LCM, and absolute value. So remember, always pause the video, try it yourself, and then unpause it and come back to see how you did. The first one, we're focusing on the GCF, which is the greatest common factor. So it's the biggest number that can go into both of these numbers. And the easiest thing to do it is like an upside down division sign, okay, or they call it the upside down cake. Okay, so what can go into both 42 and 36? Yeah, 6 can, because 6 times what is 42? 7. And 6 times what is 36? 6. Now, can anything else go into 7 and 6? Nope, you're done. So it's a 6. Now, if for some reason you didn't see that right off the bat and you're like, oh, they're both even, so 2 can go in. Well, how many times does 2 go into 42? 21. How many times does 2 go into 36? 18. And then you would look at this and you would see, oh, 3 can go into both of those, because 3 times what is 21? 7. And 3 times what is 18? 6. Can anything go into those? Nope. So then along the outside right here, 2 times 3 still equals that 6. So no matter what, you got a GCF of 6 for that first one. Okay. Again, if you haven't tried them yourself first, pause it, try it, and then come back to see how you did. Okay, what can go into both? 2 goes into 24 12 times, and 2 goes into 20 10 times. Are you done? Nope, because 2 can go into both of those. 2 times 6 is 12, and 2 times 5 is 10. Can't keep going, so 2 times 2 is 4. And some of you guys just started with 4, and 4 times 6 is 24, and 4 times 5 is 20. So you would have gotten there faster. Okay, what can go into 24 and 16? Yeah, 4 can. And 4 times what is 24? 6. And 4 times what is 16? 4. What can go into 6 and 4? 2. 2 times what is 6? 3. And 2 times what is 4? 2. Can you keep going? Nope. So 4 times 2 is 8. That is your GCF for that one. Okay, anything that ends in 0 and 5 is divisible by? Yep, 5. 5 times what is 30? 6. And 5 times what is 25? 5. Can you keep going? Nope. So 5 is your GCF for that one. Okay, our next one. You have 40 and 50. Anything that ends in a 0 is divisible by 10. 10 times what is 40? 4. 10 times what is 50? 5. Can you keep going? Nope. So that one had a GCF of 10, meaning the biggest number that can go into both is 10. What's the biggest number that can go in here? Well, what do you see? I see a 6. 6 times what is 24? 4. 6 times what is 36? 6. Are you done? Nope. You can keep going with a 2. 2 times what is 4? 2. And 2 times what is 6? 3. Can you keep going? Nope. So that's your GCF. 6 times 2 is 12. Now, some of you guys started with 12 or with 3 or with 4. It doesn't matter as long as you keep going until you can't go anymore. When you multiply the numbers along the side, you should have also gotten 12. Okay, now this time we're finding the LCM. It's the least common multiple. Multiple is not numbers that can divide into, it's numbers that they can both multiply to become. Okay, so like 20, 40, 60, 80, 30, 60, 90. Those are the multiples of like 30 and 20. Okay, you want to find the smallest one that both can multiply to become. So to figure that out, I mean, you could list all the multiples and find the first one they share. Gross. Or it's the same process we did before. Okay, so you have like 10 can go into 30 3 times, 10 can go into 20 twice. And instead of being like, oh, it's 10, no. That's the smallest factor that can go into 30 and 20. But the multiple is what can they multiply to become. And to figure that out, instead of just doing this, I do the L for LCM along the outside, 10 times 3 times 2. Well, 10 times 3 is 30. 30 times 2 is 60. So 60 is the smallest number that both 30 and 20 can multiply to become. Pretty cool, right? And then you're like, okay, well, what about when you have like something like this? Nothing can go into 12 and 13. You're like, well, technically 1 can, because 1 can go into everything, right? So 1 times 12 is 12, and 1 times 13 is 13. And then when you go to multiply these, you just have 1 times 12 times 13. So the smallest number they both can multiply to become, well, 12 times 13 is 156. Okay, this one's a little bit easier. Go ahead and try it. Okay, you're back with us. What can go into both? 2 can go into both. 2 times what is 22? 11. And 2 times what is 8? 4. Now, can anything go into 11 and 4? No. So then I go ahead and I multiply all these along the outside. So you have 2 times 11 times 4. Well, 2 times 11 is 22, and 22 times 4 is 88. So the smallest number that they can multiply to become is 88. Now you have 36 and 27. What can go into 36 and 27? I see 9. 9 times what is 36? 4. And 9 times what is 27? 3. Can anything go into 4 and 3? Nope. So you're done. Do the L for LCM. Okay. 9 times 4 times 3. Well, 4 times 3 is 12. 12 times 9 is 108. So that's the smallest number that both of those can multiply to become. Okay, 40 and 30, they both end in 0, so I know 10 can go in. 10 times what is 40? 4. And 10 times what is 30? 3. Can you keep going? No. So then do the L for LCM. 10 times 4 times 3. Well, 4 times 3 is 12, and 12 times 10 is 120. Okay, so 120 is the smallest number that they both can multiply to become. Last one. If you haven't gotten any right yet, this is your time. I can feel it. Okay, so 35 and 10, what can go into both? 5 can, because 5 times what is 35? 7. And 5 times what is 10? 2. Can anything go into 7 and 2? Nope. So do your L for LCM. 5 times 7 times 2. Well, 35 times 2 is, that's right, 70. Okay, hopefully you got that right. Now on to our last ones. Our next section is to simplify these, what are those bars called again? Yeah, absolute value signs, meaning how far is that number from 0? And since it's a distance, distances are always positive. So right here, how far is 3 from 0? 3 away. Okay, what's the absolute value of negative 3? Or how far away is negative 3 from 0? Okay, if here's 0, 1, 2, 3, 3 is 3 away, and 1, 2, 3. Negative 3 is also 3 away from 0. So both of these are positive 3. This one is a little bit trickier. Okay, so what's the absolute value of 3? The absolute value of 3 is 3. And then on the outside, it says that there's a negative. So what's the opposite of that? A negative 3. Okay, what about here? Inside, what's the absolute value of negative 3? 3, because negative 3 is 3 away from 0. And then what's the opposite of that? A negative 3. What did you notice? Anytime that there was a negative out in front, your answer was negative. But if there was no negative out in front of the absolute value bars, then your answer was positive. Inside, whether it starts as a negative or a positive, it still is a positive distance, right? So go ahead and try these. Okay, what's the absolute value of negative 7? 7. What's the absolute value of 7? 7. What's the absolute value of negative 7? 7. And what's the opposite of that? A negative 7. What's the absolute value of 7? 7. And what's the opposite of that? Negative. Hopefully you got those right. Okay, on to the last one. Pretty tricky here. You're going to put these in order from least to greatest. Whenever I see the word least and greatest, I like to underline the word least once and the word greatest twice. So it's kind of a visual of small to big. And then sometimes it'd go greatest to least, so it'd be big to small. So I just like to underline it like that so I can get a visual. This time they're looking for small to big. Okay, and then I also do a little number line every time I have these, just so that then I can see as a reminder, like, of course, this is easier. I know 3 is bigger than 2, but with the negatives, I sometimes even get messed up. Like, negative 3 is actually smaller than negative 2, because think about it. I'd rather owe $1 than owe $3 to someone, right? And like the closer you get to 0, like the smaller the negative it becomes. So when you want the smallest number, you're looking for the biggest negative. That's actually the smallest value. So here are all your negatives. What's the smallest one? It's actually the negative 3. Then what? Okay, so negative 3 is here. Then you have the negative 2.5, right? Because 2.5 is between the 2 and 3. Then what? Then the 2. Okay, and then the negative 1. And then you have 0. Okay. Now, out of these, what's helpful is I like to put the same number of numbers after the decimal just so I can compare. Since there's two numbers after the decimal here, let's make sure that has 2, add a 0 so that has 2, add a 0 so that has 2, and add a 0 so that has 2. So now you can easier compare, okay, anything smaller than 1, yeah, this 0.40 or 0.4. Okay, 1 is right here. I have 1.50 or 1.48. Well, what's smaller? Actually, 148 is smaller than $1.50, right? But if you didn't put that 0 right there, you would have actually maybe fallen for the trap and thought 1.5 is smaller than 1.48. No, but this actually stands for $1.50, right? So that's why it's really helpful to put 0 placement holders if needed, so you can compare, like let them have all the same number of numbers after the decimal, and then you can see, oh, this is actually bigger than this, because I bet a lot of you accidentally switched those. Okay, so I have less than 1. Here's the ones. Okay, for 2s, what's the smallest? Okay, the normal 2, so like $2. Then what? The 2.15, and then the 2.30. Again, if you didn't put that 0 placement holder, you might have been tempted to switch those. Okay, and then double check. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. All right, and then you have them all in order from least to greatest. Congratulations, my little mathematicians. You hopefully now remember how to do greatest common factors, least common multiples, absolute value, and ordering from least to greatest. You got this.